You have seen in the previous video that when you install Oracle Express, you end up with one control file and two redo log files. You probably don't see anything wrong here, but this is a situation that makes many inexperienced DBA cringe, and I'm going to try to explain you why. When you start Oracle, it begins by reading the parameter file spfile.exe.era. As we shall see soon, the parameter file contains the name of the control file, that in turn contains the names of the various data files you have seen in the previous video, as well as the names of the online log files. I just show one here because at any given time only one is active. But it doesn't just contain names, it also controls whether files are up to date. As they are written asynchronously, they may be behind if the database wasn't properly shut down. In that case, the online log that was last active is used to bring all data files up to date, which is why log files are often called redo log files. The control file is also very important for backups, because Oracle's backup utility will usually store backups to backup sets that have no obvious relationship to data files. The relationships are usually stored in the control file. In other words, control files and redo log files protect data files. But what protects them? Nothing. Hardware failures happen, and human errors happen more often. As paranoia is a virtue of a good database administrator, an Oracle DBA usually wants those files mirrored to another disk. Oracle knows how to maintain the multiple copies. The administration tool that is provided with Oracle Express has no facility for mirroring files, and you'll have to do it with Oracle's trusted command line tool, SQL+. If you want to become an Oracle DBA, you'll probably use it pretty regularly. Real DBAs all use SQL+ very often. Even if the other editions come with a more serious GUI tool for administering the database, SQL+ is invariable in scripts, and you should be familiar with it. If you are on Linux, connect to the Oracle account that was created during the installation, and ensure that you have Oracle Home correctly set in your environment, as well as Oracle SID, and that your path contains Oracle Home/bin. You probably want to set these variables in your bash profile. On Windows, everything is in your registry already. Before using SQL+, I advise you to navigate to Oracle Home, SQL+ admin, and to edit the file called glogin.sql. This file is always read when you launch SQL+. Add to this file the following: define_editor equals, and Notepad if you are on Windows, or gedit or vi if you are on Linux, or whichever text editor you are comfortable with. This will allow you to easily edit your commands, as I'm going to demonstrate shortly. To use SQL+, you must open a terminal window and type SQL+/ as sysdba. / takes the place of the username and password that you usually provide. As sysdba suggests, you are here identified by your system account, not by Oracle. On Linux, you must belong to the same group as Oracle to be able to use this way to connect to the database. You can now type SQL commands to the prompt. Commands are kept in a buffer and executed when you type either a semicolon or / as the first character of a new line. I'm going to mistype something on purpose. This query should give my username, but I've mistyped from. I just have to type ed, it saves the last query to temporary file and opens the editor I've specified in glogin.sql. I correct the mistake, save the file on exit, it's re-imported by SQL+, and I just have to type / to run it. As you can see, I am connected as sys, the most powerful user in an Oracle database. But first, let's modify the settings so that Oracle mirrors the control file. The first command to run is create pfile from spfile. What does it do? Well, the sp file is spfile.exe.era, as told by the Oracle SID in your environment. This file is a binary file that cannot be easily edited. The create statement copies its content to a file named not pfilexe.ara, but initxe.ara in the same directory on Linux and in the database directory on Windows. This will allow us to edit and change the parameters. Most parameters can be dynamically changed by issuing special SQL statements, but as the control file is so vital, it cannot be changed dynamically. Next, we are going to shut down the database by issuing shutdown immediate. Then, we can exit SQL+. Next step, we must edit initxe.ara. On Windows, don't use Notepad to do it, but WordPad, because Notepad doesn't recognize line breaks. You see that some parameters are prefixed by xe and most other ones by star. It's possible with other editions to have two instances of the database accessing the same set of data files. Parameters are preceded by star when they are common to all database instances, and by the instance name when they can be different. So, this is my Windows parameter file. Here is the parameter I want to change. You can note that it's control files, plural, and I just add a comma and the name of my copy of the control file between quotes. I save the file, and of course I must copy the original control file to the location I've specified. Remember, I've shut down the database. I couldn't do it if it were open. Now let's use SQL+ again. Idle instance is the Oracle way to say that the database is down. First thing, I execute the command create sp file from pfile, which is just the opposite of the command I ran to create initxe.ara. As you can guess, it takes initxe.ara and regenerates a new sp file xe.ara binary parameter file. Once this is done, I just have to run startup. I can type show parameter control files to check that my two files are taken into account. Now, let's deal with redo log files. The way they work is that every time you commit a change, it may not be written immediately to database files, but it is immediately recorded to the current redo log file. When the file is completely written, it triggers a flash of memory changes to database files, it's called a checkpoint. Then there is log switch and the other log file becomes current. When this one becomes full, log switch again and the other file is overwritten, because the changes it records have been at this stage applied to the database files, its content is no longer needed. When you mirror redo log files, the same information is simultaneously written to two files, which should be on two different disks. Two or more files that are simultaneously written constitute a group. Individual files are called the members of the group. To display the current status, I'm going to query a view called VDLLog. The Oracle Data Dictionary contains many views called VDL something that are simply the mapping of relational views to data structures that contain volatile information about the current state of affair. VDLLog tells which redo-log group is currently active. To add a new redo-log file to a group, I just have to issue the command alter database add the file name to the number of the group. No need to specify the size, it will necessarily be the same size as the existing file. Alter database is the command that you usually use to modify the structure of your database, to add, resize, or remove files most often. I execute the same command for the other group, and then I can query VDLLog again to check how many members I have now. But VDLLog only gives a global picture of groups, and I may want to query VDLLog file to have information about individual members, and here the picture doesn't look so good. But in fact, the status invalid is easy to understand. As we have just added the files, they aren't yet exact copies of the original file. What I am going to do is manually trigger a redo log switch. For that, I use the alter system command that is used, Ctrl-A to alter database, to change not the structure but how a currently running system operates. This really brings in the system one of the two files I have added. I switch again, and now both files are fully operational, as I can easily check. So at this stage, we have mirrored both the control file and the reader files to different disks. We can now give a first look at the administration toy, but before that I want to show you how you can change the HTTP port on which it listens if 8080 conflicts with something else. This is more particularly for Windows, as you cannot configure again as you could with Linux. You change the port by calling a stored procedure that takes the new port, for instance 8081, as parameter. This procedure, set HTTP port, belongs to a package called dbms xdb. But remember that my HTTP server is the listener. I must therefore warn the listener to listen on the new port, which I do by issuing alter system register, what is normally automatically done when the instance starts. We can quit SQL Plus and run lsnr ctl to check that the listener is aware of the new port. So, let's now point our browser to localhost :8080 or whichever port you have specified /apex. On the login screen, you can connect as system with the password you have specified during the installation. Then you see the main page, and what you should look at is at the bottom right. What an Oracle Production DBA doesn't like is this: log archiving off. What is log archiving? Well, it still has to do with the reader log files. When log archiving is on, a special process copies the reader log file in the group that is no longer current and saves it, so that you still have a copy of it when it is later overwritten. Archiving reader logs is required if you want to take hot backups, which means taking a backup of your database while it is running and that people are changing the data. And if you want your database to power a website, you usually want backups, but no downtime. Archiving reader logs is necessary for one very simple reason. When you copy a file, it can never be an instant operation. It takes some time, which depends on the size of your file and the performance of your disks. If you start the copy of the file while it's been modified, at the end of the copy, the file will be different. And what will the copy look like? It will be neither the image of the original file at the beginning of the copy, nor the image of the file at the end, but something in between that very probably the original file never was. But it will not be a problem for Oracle if you have all the reader log files that were generated during the copy, because by applying them, it will be able to turn the copy into the exact copy of the original file at the end of the backup. But this only works if you have all the reader log files. If you have wrapped around your groups, ouch! Then you are in dire straits. So, let's quit the administration tool. I'll come back to it in another video, promised. Return to SQL Plus, and once again, let's shut the database down. We cannot change the logging mode dynamically, and we must record it in the control files. I'm going to start the database, but with a twist. The mount parameter tells to open the control files, but not to open the data files for regular access. A simple alter database command does the trick, which I can follow with alter database open to make the database accessible to all users. I can then switch the log files a couple of times. Where are all the archives gone? If you go to the Flash Recovery Area directory, you will discover that you have a new directory called archive log with a subdirectory that is the timestamp for the day. There, you'll find today's archived files with the .arc extension. Now, your database looks more like a serious production database. Next time, we'll explore the administration tool and still do stuff with SQL Plus.